So on your calculator, there are two logarithms. And the one is an LOG button, which almost everybody has in I think everybody has in this class. And above LOG, you see 10 to the x. And the other one is the LN button, and above the LN button, you see e to the x. And these is the function and their inverse. Now what it's telling you is here that log LOG is base 10. So it's called the common logarithm. So if I had LOG of x and I needed to work with it, I could substitute LOG base 10 of x. And the same down here, ln is base e, so I have ln of x. If I need to work with it, I translate it and transform it or rewrite it into log base e of x. And so if I just needed to do a calculation, I would just put in the number, and which is easy enough to do, and put in ln of 25, and I could get an answer out with no problem. I could take log of 25, no problem. However, if I was working with a formula or an equation that I was trying to solve, and we'll see that in 10.7, then I'd have to rewrite natural log as log base e and common log as log base 10. And these are approximate numbers whenever I go to do a calculation. So you notice these guys come out to be long decimal numbers. They're what we call irrational, which means they never terminate and never repeat. When you get something like that, I could take the log of 10. That comes out to be a nice number. But if you've got a lot of decimals, you're going to be doing a lot of rounding. That means when you're doing calculations, you can end up with round-off error. It says approximate each logarithm to 2 decimal places. The log of 30, so it's log. So log 30 is 1.48. So this is approximately 1.48. And then we have ln, that's natural log of 0.04. So ln 0.04 is approximately negative 3.22. That's all there is to it in using your calculator to do logarithms. But unfortunately, we're not done yet. Don't turn your page. Got something at the bottom. Unfortunately, these guys are on my calculator. This guy is base 10, and this one, remember, is base e. So I can do it on my calculator. The problem tends to be is what if I wanted to calculate out instead log base 3 of 15. I don't have that on my calculator. If this were base 10, I could do that. If this were base e, I could do it. But I can't do this directly on my calculator. That's why we have something called the change of base formula. And that's why we have to be very careful between the properties of logs and once this guy is introduced. Change of base formula allows you to be able to not only on the graphers to graph logs that aren't base 10 or base e, or to calculate values for logarithms that are base 10 and base e. So what it says is this: if I have log base b of m, it's the log base a of m divided by log base a of b. Now to me, that base a doesn't have any meaning. To me, it would be the log of m over the log of b. That's base 10. Or it's the natural log of m divided by the natural log of b. That's base e.
You got ln. ln.
LNM, LNB, so natural log. These are on my calculator. So they're on my calculator. Now, what they're doing is say you can do this to any base, but I want to translate into something that's on my calculator. So this guy would say is that M is the argument, B is the base, that you're going to take log of 15 divided by log of 3, and that's how you're going to do that calculation. So log of 15, remember, close parentheses, otherwise it brings the denominator in to this logarithm. Log of 3, and it is approximately 2.47, so approximately 2.47. I like to look at it as this. As this is the log of the argument. And remember, the argument is what you're taking the logarithm of, divided by the log of the base. The log of the argument divided by the log of the base. And that would be the same whether it's log or ln. Because that enables me in college algebra then to, because we do a lot of graphing with our calculators, is to basically use my calculator to graph things I wouldn't be able to graph otherwise.